Okay, I've got a real big mouth, so I don't know if I need a microphone or not, but
Holy.
I don't have a big mouth. My mother said I did. If your mother says that, it's got to be true. So, yeah, I'm going to talk to you a lot of things today, especially about Mars. That's why you're here, obviously. But also some things about history, economics. It's all kind of related to our space program. My laptop fired up here. Ready to go. What I'll do is I'll go through a series of PowerPoint presentations, and then if you can save your questions for later, that way I can get through all the slides and see all the pretty pictures I've got. And if there's a picture you want me to go back to, I can always scroll back and get to a specific question on that. So we can do that.
Yeah. I mean, I'll be able to run the machine.
Is that okay? Okay. This title, America's Triumphant Return to Mars. The reason I have it on there is back in 1999, December 3rd exactly, I was working on another Mars mission that NASA sent out to Mars, the Mars Polar Lander. It crashed on Mars, December 3rd, 1999. I lost my job. A lot of other people did too. Going to Mars is a hard thing to do, and I'll talk about it later in a slide, a graphic to show you how hard it really is to go out there and explore. But as you well know, the Columbia accident back on February 1st, 2003, took the lives of 7 astronauts. NASA was in a bad state of affairs, big black eye, like it couldn't do anything right. We were told several times in our science team meetings from the higher-ups, and Dick Cheney is a golf buddy, the NASA administrator, Sean O'Keefe. Cheney told him several times that these 2 rover projects missions better work. It costs $800 billion. Excuse me, 800 billion. Not that much. 800, not quite a billion, 800 billion. It's a lot of money, and the pressure was on us to make these things work. The last time the United States went to Mars, we had 2 failures in a row in 1999. The orbiter failed, it burned up the atmosphere. You probably remember that one because the unit conversions weren't right between metric and standard. It wasn't a simple thing like meters and feet. It was more complicated, but it was an error that should never have happened, a school board error. And then we lost Mars Polar Lander because the retro rockets didn't fire. But so we had the pressure on us, and really that was kind of a good thing. But a little bit of history. 500 years ago, there was a guy named Christopher Columbus had his dream, his vision. And his vision he pursued for several years, about 7 years before the King and Queen of Spain finally financed his trip. His trip cost about the price in those days of a state dinner. Put it in perspective for you. He had been denied, like I said, for 7 years. He started out in Portugal. Portuguese didn't want any part of it. Went to Spain. And he was told by the chief of economic affairs of the Spanish government at the time that we're not going to fund this. It's a pipe dream. It's a waste of our money and time. He was actually leaving Spain. And a messenger was sent out to go get him and bring him back because Queen Isabella had a change of heart. And the reason I tell you this story, I'll let you know this story, obviously, but the thing about it is, the only reason, if you know the name of the King and Queen of Spain, it's because of Columbus. And I don't know if you're aware, if you're a historian, you know this, but in 1492, the reason you know that date is because of this voyage of exploration. Other things happened in 1492. The Spanish economy wasn't very good. There was a war with the Moors. They drove them out of Grenada that same year. You don't know anything about that, though. It's a footnote. And I submit to you right now, especially with the first lunar landing back in July of 1969, that is going to be the headline, this chapter on the 20th century. Now we're in the 21st century. Space exploration. Wars come and go. Political leaders come and go. Economies do good, do bad. Those are footnotes. The big things you remember, the big stories like this, and I think there's an example in history that proves what I'm saying. 500 years ago, this is what you think about. You don't think about some kind of dalliances with political intrigue. Think about big events. And I think the space program has direct parallels with the voyage of exploration 500 years ago by Columbus, Magellan, Vasco da Gama, those people. And if they were alive right now, I think they'd be doing what I'm doing. If I know for a fact if I was alive 500 years ago, I'd be jumping on those ships from over here. So that's kind of a neat, for me personally, a neat thing, through the mist of time, a common link or thread between those explorers. Well, our country was founded basically when Columbus came over here and discovered the quote-unquote New World. Well, this is a picture, a painting of Lewis and Clark. The reason I put this up here is this is their bicentennial. 200 years ago, these people were commissioned by President Jefferson to go and look for the Northwest Passage. At this time, in the early 1800s, 1803, 1804, most of the population of the United States lived within 25 miles of the Atlantic Ocean. Our country was nothing when we think about it today. And Jefferson had his vision of having a country that stretched from the Atlantic Pacific Ocean. There's a lot of dealings going on with Napoleon to get this Louisiana Purchase, which at the time people thought was a waste of time and a waste of money. But now, don't think that way. Back on January 14th of this year, President Bush came out and directed NASA to finally have a new mission, a new goal. I don't know if you're aware of this, but the last time we landed on the moon was in December of 1972. We can't go to the moon today. If the president came on TV tonight and said we're going back to the moon, it wouldn't happen for probably 5 or 10 years, a crash program. The capability to go to the moon doesn't exist in this country anymore. We're the only country that's ever landed people on the moon. We landed 12 of them on there between 1969 and 1972. We threw that away for a lot of reasons. The Vietnam War was raging, Watergate. Congress said, we've got the goal, Kennedy's goal, we made it by the end of the decade. This is kind of like, we don't need this anymore. So it was thrown away. So NASA, since the Apollo program, really hasn't had a directed goal, a vision. So the first time, it's 3 decades overdue, it's out there right now. It's going to have a big, long fight in Congress to get funded. It remains to be seen if it's going to get funded. But for the first time, a president has made a stand. Well, actually, his father made the same stand in 1989, and Congress had no part of it. So he's fulfilling a lot of his father's promises, I guess. He got rid of Saddam Hussein, and now maybe he'll get us to Mars. But we'll see what happens here. But at least NASA now has a goal. It's been a ship without a rudder for a long time. And doing laps in low Earth orbit, it's boring. Most of you probably don't care anything about that. I bet you most of you can't even name the 2 astronauts who are currently on the space station right now. One American, one Russian. It's just not very exciting compared to going to the moon. I was lucky. When I was a kid, I remember when we landed on the moon. I was 10 years old when Neil Armstrong and Buzz Aldrin landed on the moon. And I could walk out in my backyard, look up at the moon, know 2 Americans were walking and working up there. That was really a strong feeling for me because it was something that's tangible and real, and all my life is what I wanted to do. And I've been lucky and fortunate to be where I am right now through a lot of help of other people. Other thing I always get when I give a talk about the space program is it worth all the money we spend on there? And so I went through and this was checking and got some numbers. We spend about $300 billion a year on defense. I don't want to go through all these because I know you can all read it here. But this perspective, it's all about perspective. NASA's budget is about $15 billion a year. It's been flat for the last decade, not even compensated for inflation. Now you can see what we spend a year without even thinking twice about it. Pizza, beer. I'm not saying you shouldn't drink pizza or eat beer or buy flowers. I'm saying that, put in perspective, when you hear that number, it's not like NASA writes a check one afternoon for $15 billion. Now that's spent. People pay their salaries, technology funds these missions. It creates us that we have this quality of living we have right now. Like I said, it's about perspective. You go buy a cup of fancy Starbucks coffee, it's $3.50. You don't think twice about that. Those rover missions that are up there working right now, you spend 91 cents a year for 3 years. Okay, each hamburger costs that. So it's perspective. And once again, going back to history, during the Apollo program, the heyday of NASA, when its budget was at its maximum, for every dollar that was spent on the space program, $10 came back into the U.S. economy. And I'll tell you a story that everybody probably has a computer in their house now, definitely probably a cell phone, microelectronics, and calculators. That all came from going to the moon. The reason it came from going to the moon is because you had to miniaturize all the electronics. If something's big and bulky, it's heavy. If it's heavy, it takes a bigger rocket to get it up there, and that means more expensive. So this miniaturization is what was really spurred by going to the moon. Now, to be honest with you, I'm not going to sit here and tell you we would never have these products if we hadn't gone to the moon. But we would not have them right now today. You wouldn't have your laptops, your cell phones. It may be a decade or 2 down the road. It would have happened eventually, but it spurred it on. And space program, dumps money, this isn't a high chart kind of, but money goes to every state in the union for NASA research, some more than others. But now moving on to Mars. That's why you're kind of here. I feel like I'm an evangelist today, preaching to you. I'll pass the collection plate around for NASA later. But Mars is about 1/2 the size of the Earth. The interesting thing about Mars is a day on Mars is almost like a day here on Earth. about 37 minutes longer than a day on Earth. Well, believe me, that wreaks havoc with you when you live on Mars time. But these rover missions from January up until about a month ago, all the science team members, we were living on Mars time. And you think, well, shoot, it's almost 40 minutes longer each day, you get to sleep longer. No, it didn't work that way. And your shift is constantly changing, because say you come in at 8 a.m. to work, about 12 days later, you're pulling the graveyard shift. It's always going around. 40 minutes each day adds up. And you're working all kind of crazy hours. But the first month after we landed in January, I never saw daylight. We were sleeping during the day, going at night. It's a crazy schedule. It's very taxing on everybody. But we made it through there, and we set a bunch of records. We're the group of people who've lived the longest on another planet's time, first to ever do that in history. So we got a lot of firsts, but some are pretty tough. But gravity on Mars is about 38% what we have here. The atmosphere is very nasty, though. It's very thin. It's mostly carbon dioxide gas. But it's very thin atmosphere. The pressure is 1% what we have here. Another way to think about that is if you're 20 miles above the surface of the Earth, that's about how thick the Martian atmosphere is. Almost nothing there. Very cold place. A lot of people think Mars is hot. I guess because it's red, I don't know. It's the fourth planet from the sun. But to give you an average temperature, global temperature average is about 70 degrees below 0 Fahrenheit. It's a very cold place. It's a frozen desert world is what it is. One interesting thing about Mars, a lot of interesting things, but you took all the 7 continents, balled them up. That's how big Mars is. To give you an idea, the moon is about the size of Africa, balled into a sphere. So you got the Earth, Mars, and the moon, a little progression of sizes there. One reason we're interested in Mars, I think the first thing you hear the word Mars, think about life on Mars. Is there life there, or was there life there? And we don't know the answer to that question right now. We know a lot more now from these rover missions than we did before. But I'll go through this. This is our philosophy or our mantra for Mars exploration. It's follow the water. And where there's water, that's where there's a good possibility there could have been or is life. Water has a big role in the climate, obviously in the geology. And when we send astronauts there, it's going to be a very good, valuable resource. Anywhere you go to Earth, on the planet Earth, you find life, you always find liquid water there. It can be in Death Valley. It can be in frozen lakes in Antarctica where I scuba dived in. It doesn't matter the temperature, but you have to have liquid water there. Liquid water is like the quintessence of life. You have to have it. There are certain rocks in Antarctica, you crack them open, there's like algae that lives inside there. So if the liquid water gets from the snow melt, it infiltrates through cracks. You don't need a lot of water, but you have to have liquid water. So our understanding of biology is very primitive. It's based on one example, what we have here on Earth. So we think life is going to work like we understand it here. It might not, but based on that's all we got to go on. We think this common thread linking all these fields of endeavor is water. And I'll mention briefly about human exploration. This glass of water thing on your table there, which you don't think twice about, it's very important. On Mars, it's there, but it's frozen. It's a form of ice right now. Mars has polar caps like the Earth does. It also has a lot of ice locked up in the ground. It's something called permafrost, like you do in the high latitude regions on Earth. You dig down on Mars, you get ice, which is dirt. Well, you get there, you can obviously melt that ice, you get drinking water. It saves you a lot of weight. All the water, you got to purify it, probably, but you got drinking water. Another thing neat about water is you can break it apart into hydrogen and oxygen, and you got oxygen to breathe all of a sudden. You got hydrogen, which is the fuel. And what's special, it lifts off that big orange tank, the external tank, the giant gas tank, it's filled with liquid oxygen and liquid hydrogen. It's rocket fuel. So water gives you rocket fuel, gives you water to drink, you need that, gives you oxygen to breathe. So water is the most valuable resource in space exploration. People have always been interested in Mars. It goes back to prehistoric times. I think Mars, because it was red, it was different from the surrounding stars, and it moved around like all the planets. The word planet is a Greek word, it means wanderer. The planets wander with respect to the background stars. You watch them through the seasons. And early ancestors watched the sky a lot. They didn't have TV or books. And the sky was their calendar. They learned when to plant crops eventually, all this. So that's why if you go out and look at the Big Dipper, in Greek mythology, that's the giant big bear, Ursa Major. It doesn't look like a bear to us, but these people had vivid imaginations. Also, they had darker skies than we have nowadays in big cities. But so the sky, looking at the sky has always been an integral part of our history. And in a way, we kind of came from there. Carl Sagan used to say, we're made of star stuff, and it's true. If you ever wonder about where the iron in your blood comes from? It came from a star that exploded in a supernova phase billions of years ago. Calcium in your bones came from the internal furnace of a star that's long gone. So the minerals that make up our very body from stars that exploded. And so we are literally made of star stuff. And there's kind of like, we look out to the heavens at night, and everybody in this room, I would be willing to bet a good chunk of money, at least one time in your life, you've looked up there on a clear night and wondered, is there anything else out there alive? Are they looking at us? What am I doing here? How do we fit in the overall scheme of things? Some people are more curious than others, but everybody has that curiosity and wonder. You can see, this is a brief timeline, and I'm going to jump up to the present day here. But last August, it was interesting. It was the closest Mars had been to Earth in 60,000 years. 60,000 years ago, we were living in caves, like Neanderthal man here. And now, the ancestors of these people, us, we got the capability to go to Mars. A red dot these people saw, very close prominently in the sky. Last summer, you probably saw Mars. If you didn't know what you were looking for, you probably did see a red dot up here. You thought it was a pretty bright star. That was Mars. Well, I said Mars is a hard place to go. And the Earth, when I say Earth, it's the former Soviet Union / Russia, U.S., Europe, Japan, have sent a total of 34 missions to Mars. Only 13 have worked. Those 13 have worked in all American, by the way. But we've had our share of failures also. 2/3 of the missions have failed going to Mars. Tough place to go. And so we keep on trying to keep on going. And as a kid, I told you I grew up with the space program. This is my room. As a little kid, I used to build model rockets, had pictures of astronauts all over the wall. I used to write letters to the astronauts at NASA centers and fly model rockets. As a book report I did. And then last summer I was down at Cape Kennedy. This is our rocket, a Delta II rocket back here, that launched our rovers to Mars. So, like I said, I've been interested in this all my life, and I've been lucky to be able to do what I dreamed about. Well, these are the stars of our show right now, the Mars Exploration Rovers. They have the name of Spirit and Opportunity. This is pointing out their scientific payload. We have a big panoramic camera up here. Interesting enough, this is about 5.5 feet above the surface of Mars. That's roughly about a person's eyeball height, give or take a couple inches, okay? So it gives a nice perspective when you see these pictures, almost like you're standing here. We have other cameras down here in the belly of the rover, hazard avoidance cameras. If you're ever seeing those pictures, it looks like you're crawling along the surface. And if you ever, for a sense of perspective, think about how you see the world normally, and then lay on your belly, look at the ground. Things look differently. Rocks look giant, stuff like that. Distances look very different. So we have a series of cameras on here for our navigation and science analysis. This is the what we call the IDD, the Instrument Deployment Device, or the ARM. It folds up when we drive, but we can extend it. And this is a rock abrasion tool that actually drills into the rock, cleans off the dust and the crud, allows us to see fresh exposure of rock. And as geologists, rocks are like pages of a history book. And you probably, most of you think rocks are pretty boring and who cares about them, they're in their way, they stub a toe or something. But like I said, rocks are pages of a history book. And if you know what you're doing, you can look at the landscape and look at the rocks. It tells you what happened there and how this landscape developed. So that's what we're doing on Mars right now. We have tools to do this. These robots, these rovers, this rover weighs about 400 pounds on Earth, the size of a golf cart. It's the most capable and largest rover ever been sent to another planet. Its top speed is, literally the top speed of this thing is the speed of a Galapagos tortoise. How fast it will go. Very slow. Well, this is down at the clean room at Kennedy Space Center. That rover was all folded up. It's buttoned up inside the cruise stage here. You can see here the heat shield and the back shield here. If you can sense the scale of these people, you see it's a pretty small vehicle here. Well, Warner Brothers gave permission to use these characters for these patches for the mission. And this is obviously Marvin the Martian, Daffy the Duck. This is Mur A. This is the rover that landed in Gusev crater on January 3rd, the first one. And this is Mur B, or it's called Opportunity. It landed at Meridiani on January 24th. This is down at the Cape. This is a unique picture because this is the rocket that launched the first rover. The second one, you can't tell it here, but the second one's on the pad over here. So both of them were sitting on the pad, and they launched about a month apart. But down at Cape Kennedy, if you've ever been there, there's a lot of bad weather down there, especially in the summertime. Storms build up in the afternoon, it rains, lightning. Here's our launch pad. We're supposed to launch this day with this big front rolled in, and the launch was scrubbed. It's canceled several times, and if you ever watch the shuttle program, you know that the whole shuttle launches get canceled because of weather conditions. Finally, on June 10th, the first one took off, and I was able to go down with both these launches. It was really a great experience. The second one was a nighttime launch. This is the one that landed in Meridiani, July 7th, roughly a month later. This was very interesting. This whole story of Meridiani is interesting because This is the one that made a major discovery of a lake, maybe even ocean on Mars. We found proof of that. But it almost didn't get launched. The reason it didn't get launched is you have launch windows when you go to different planets. You got to launch a specific period of time or you miss it. The launch windows for Mars roll around every 26 months. If you miss it, you wait 26 months to go again. So we had basically about 3.5 weeks for each one of these launches to occur. This one had a lot of technical problems with the rocket. Its insulation was falling off, weather, all kind of problems. And it was only had about 8 days left in its window to go, or it would never have gone. And it's doubtful, probably never would have flown because it would have been 2 years down the road before it goes again. Price to keep everything in a clean room and up flight standards would have been too expensive. It probably would have ended up at the Smithsonian Air and Space Museum. But it was interesting how it got launched, and it's made major discoveries. After the launch of the first one, we were down in Florida, went out, had a little party. Didn't want to celebrate too much. We finally left the ground. We had a long trip ahead of us. We had to land on Mars. Last time we tried it, we didn't make it. So everybody was kind of cautious, but at least we were on our way now. These are the two sites on Mars we landed at. The first landing occurred in Gusev Crater, about 15 degrees south of the Martian equator. Second landing 3 weeks later, almost on the Martian equator, Meridiani Cloud. This is a meeting we had the night we landed. I think it was around about 8:30 Arizona time at night, Saturday night, January 3rd. The last team meeting. This is our chief scientist, Steve Squires. All of us are sitting in this big room in here. And we had a briefing. Basically, what he told us is that we're in for a very spectacular show, one way or the other. We're going to crash with the thing, we're going to land, we're going to have a great mission ahead of us. Either way, something dramatic is going to happen here in about an hour. And he said, we think it's all going to work. I never had any doubts. I was just pretty confident that this would work. We've gone through testing. This felt good. This one felt real good. But he said, we got a long haul ahead of us if we get down the ground. We're going to be working long hours. We're a team. Everybody's got different interests. We've got to work as a team. He basically told us to get along with one another. And that's a very important thing because you got people from, mostly Americans, but you got the German scientists, Denmark. You got people with all these different research interests, different instruments, pulling all over the place, want to do this and that. You can't do it all. You have to work as a team. And remarkably, we've done very well. We haven't had any problems really, even under all the stress. Well, when we landed that night, we got a signal from the spacecraft that we had airbags, the parachute deployed, we were bouncing on the surface of Mars. And then we lost communications with it. So for 10 minutes, we knew we made it to the surface, but we didn't know we were in pieces now. So we had 10 minutes there. This is the NASA administrator, he looks pretty worried. And like I said, the pressure was on. The future of NASA was on these missions here. Definitely the future of Mars exploration. And NASA needs something good to happen. But 10 minutes later, we got a signal. The thing was rolling. The antenna was going in and out of the sight of the Earth. And we finally got confirmation it stopped rolling. And everybody's pretty happy now because we knew we were on the ground and we were going to have a mission ahead of us, looked like. Next thing we wanted to figure out where were we on Mars? Where did we land? And the scientists, we wanted to know exactly. We had a landing ellipse that was about 120 kilometers long and about 20 kilometers wide. We didn't know where and we were landing. It's a lot of room in there. And it's going to depend on where you land, what kind of targets you go after for your geology investigations. So we had some images from the spacecraft sent back. On its way down, it took 3 pictures before it landed. It sent images. And this is one right here on the laptop. Then we had this big map here. It's our landing on it, so you can see it. You got good eyes. You can see part of the ellipse right here. We're trying to figure out matchup craters, landmarks. We're to figure out where we were. And we figured it out in about 2 days. All around the table here. We had a good clue that night, but we confirmed it. It took us about 2 days to figure it out. And so that was fun being involved in that. And my 15 milliseconds of fame came when the vice president came out to JPL and congratulated the team. And originally, I'm kind of tall, so I was in the very back of the crowd. And I didn't want to block the view of anybody. And some guy, I don't know if he was Secret Service or who he was, came up to me because I had a red shirt on that day and then there a logo or a patch for a mission on there. And he said, anybody wearing mission patches on a shirt should come to the front. I guess a photographer or whatever. And I didn't go at first because I didn't want to block people's view. And then about 5 minutes before Cheney came out, he said, you're going to the front. And I was like, okay, I'm going to argue. So that's how I got this picture right here. So he was close enough, about that far from me, I could have reached out and touched him. But it's not a wise thing. The Secret Service is all over. Snipers are on the building up there. Anyway, that was a fun thing to be congratulated for all the years of work you put in. Well, this is our landing craft. You can see the airbags right here. They've been retracted, deflated. And the rover was sitting up here for about 2 weeks when we drove off the first one. We're obviously off there now. We're looking back at it. This is was our home, our landscape. Well, what NASA did was to name that lander the Columbia Memorial Station in honor of the Columbia crew that died about a year ago when we landed. And that was a good honor. And there's these hills we saw in the distance. And as scientists, we wanted to go to those hills. We wanted to see those things, but they were so far away, we didn't know we'd ever make it there. They've since been called the Columbia Hills. Each hill is named after one of the Columbia astronauts in here. And these hills were about 1.5 miles away. That's a long way with a rover. These rovers are only designed to last 90 days and to drive 600 meters. Okay, if we did that, we achieved mission success. Well, I can tell you right now, as I speak to you, the first rover is right now on day 149 on Mars, way beyond the 90. The second rover is on day 127, I believe, also. So we've gone beyond our success they gave us. Our warranties expired for these rovers. We've also driven a lot further. These Columbia Hills are so far away, we're going to get there maybe next week. It's going to be great. And we don't know what we're going to find there. It's going to be a lot of fun. And it should be a good time. There's some other hills around there that were named after some astronauts who died back in January 1967. Gus Grissom, Ed White, and Roger Chaffee. Apollo 1 astronauts, they were killed in a flash fire about a month before the liftoff during a countdown practice test. There are 3 hills named after those astronauts also. And you can see them right here from orbit. Picked out there before we landed right there. Well, we kind of got fat out there because the director of the Jet Propulsion Laboratory at the NASA Center there said, well, congratulations, y'all guys landed on Mars. You got 2 rovers there, and this never happened before. We had free ice cream to eat for January all the way till, I guess, about May, 1st of May. And it's free. You walk by and it's stocked. Particularly stocked this thing. Dove bars, drumsticks, ice cream sandwiches. I remember all was in there. Haagen-Dazs, all kind of stuff. And like I said, we lived on Mars time. And a lot of times you'd be eating breakfast at midnight. And if you didn't bring food with you, there's nowhere to go get food. The cafeteria wouldn't open that time of night. So a lot of times you walk through here and see it. I remember a couple of nights I had like 3 or 4 ice cream sandwiches to eat. It was my dinner, there's nowhere to go. And this wasn't a good way to be eating, So to give you a view from orbit again, it's about 250 miles above the surface of Mars, looking down on Mars, this high resolution camera. You can see our landing site. This white dot here is where we landed. You can see you have real good eyes. Our parachute back shield landed up here, we can see from orbit. If we hit the ground, we bounced like a giant basketball. There's some bounce marks we can see coming through here. We stopped right there. We found also part of our heat shield slammed into near this crater rim up here. You can see that from orbit. I don't have a picture because it hasn't been released yet, but I can tell you from orbit, it's very remarkable. We can see the rover tracks. We drove up to this crater, then we're heading to the Columbia Hills off the picture here. We can see our tracks from orbit. It's unbelievable. We're altering another planet's face of another planet. It's really unbelievable. We wouldn't know if we could see these tracks from orbit. We could see them. It's amazing. See, as we drove up here, it's this bonneville crater. We got there right in the middle of March, and then we drove up this way. And like I said, we're off the screen now. And when we get to the Columbia Hills, we've already driven over 2 kilometers, this one rover. Remember, these were only supposed to give us 600 meters. So we exceeded far beyond what we were supposed to do. Here's our tracks from the ground, looking back. You can see our tracks right here. Very rocky place in the Goosehead Crater. We went there in hopes of finding ancient lake deposits because it's a big crater, a big channel emptied into there. It's a big hole in the ground. Thinking was that water would pond and form a lake. Well, we haven't found one bit of evidence of that right now. As we get to the Columbia Hills, we're going to find older materials, different materials. We don't know what they're going to be when we get there. Maybe that'll be the evidence. Maybe there never was a lake here. We were wrong about that. Here's just some pictures from the rover. You can see the part of the arm coming out here. And what we did is we had these brushes with the rock abrasion tool. We made this mark on the rock to clean the dust off. You can see how dusty it is up there. The dark area is the dust-free part of the rock. The bright area is where the dust is. So we clean that dust off because we want to look at the rock, not the dust, and see what the rock is made of. It tells us what minerals are there and how those minerals were deposited, what kind of environment. Was it a lake or was it a volcano, whatever. So we're also, you can see our tracks from orbit, we're also changing the face of rocks down on Mars. We're digging trenches on Mars. We're changing the planet. Well, you missed out on this, but back a couple weeks ago, Long John Silver's in in January said that if NASA finds evidence for an ocean on Mars, they'll give every American a free giant shrimp. Good marketing. Well, this was their press release here. I cut and pasted in. So it was Monday, May 10th. Between the hours of 2 to 5 p.m. you can go eat your free giant shrimp. Well, I went and did it because I worked on that project and I found proof there's an ocean on Mars. And that's the picture of the giant shrimp I got. Also, the interest of these rovers has been all over the place. You know, the cartoon on the table here of the paper, I guess. For the Road and Track magazine, this is kind of a spin-off of Joker and that Rover and Track. That's about the NASA's rovers on Mars. It really has captured people's attention. And being out there as a science team member, we also got to do some other things. Like, this is a full-size engineering model of the rover back here. And when we first landed, we wanted to know how steep a slope can these things really go up safely over rocks and loose soil without sliding back or tipping over. So I got kind of like in charge of a group to go into this test bed area out of JPL in Pasadena, and with all this dusty red Martian-like rock and dirt, we think is a good analog for it. Go out there and build slopes with pieces of plywood and rocks and throw dirt on it, let the rover drive up and down and see what it can do. So we're in there, and it's a real dusty place. We have to wear like masks, inhaling all the dust. We have this guy's a water tank right here trying to squirt it, keep it all damped down. Didn't do very good though. So that was kind of fun to go out and get with engineers and figure out what we can do with these rovers. This was a picture taken before we got dirty, obviously, all the dirt. And there's a picture. This is another full-scale engineering rover back here. These actually move around up on the lander on a test bed in there. So that was kind of neat to go and work with some of the hardware over there. We also, this is the landing lips in Meridiani. We landed the second lander rover. If you look, these are all these little dots here have numbers next to them. It was a betting pool we had to figure out who would pick, figure out where we landed, who would guess where we landed. And the person that won that was a school teacher who was out with a group of kids doing some intern work. And he won like about $240 in pool, so that's a pretty good deal. Here's a picture of this landing site from orbit again. And this is where these rockets fire right before we land to slow us down more. You can see the rocket firings disturb the surface right there, maybe a little lighter in color. Our back shell and parachute are sitting over here, our heat shield out here. It was amazing to see our hardware on the surface of Mars. It was just unbelievable. The neat thing, though, in this little dinky crater here, about 60 feet in diameter, we can see ourselves in there. We landed in the crater on Mars, a hole in one. And it was unbelievable. And this is a crater here, I'll tell you the name of it. It's Endurance Crater. We're there right now. It's a 750 meters. We're up about right here right now taking pictures as we speak. And I've got some pictures I'll show later that just came down yesterday. I'll show you. Well, that landing site was named after the Challenger astronauts who died in January 1986. And it's called the Challenger Memorial Station. And this is an amazing picture, I think. This is the crater right here. That's us, a lander. After we've driven off the lander, it's the rover sitting right over here inside this little crater. We lived here for about 2 months when we left this crater. This is just an artist's graphics film to show where the lander rover are. But we found something amazing there, and it has forever changed our view of Mars, really confirmation, scientific proof. This is a very flat place. To tell you how flat it is, we landed this little crater. It was about 10 feet deep. In places the rim was a little lower so we could look out of the rim. We looked out of the rim, 440 meters, and guess what we saw? Our parachute right here, and our back shell sitting out there. That's how flat it is. Looking that far across, it's nothing but a flat plane. And we're probably going to drive and look at this thing in a couple weeks, a month or so. We'll take a look at it, look at the heat shield, see how it survived for re-entry, for possible engineering designs or redesign of new heat shields in the future, and see how the parachute held up. That's pretty neat to see that. But this, to me, is the most famous picture we took so far in these missions. I think it forever will be ingrained in my memory. The night this picture came down, this was the second landing in Meridiani on January 24th. And we landed, we didn't know where we landed in at the time, you know. Now we know we were in a crater. We landed, opened our eyes, we saw this stuff right here. And I'll tell you, in the room, scientists were like gasping. You could hear it. Like, what is this? And people were going, oh, it's amazing. This is like, to us, what we want is bedrock. It's a rock on Mars in place. And our camera is still folded down. It hasn't been extended. So we're sitting there looking sideways. We came out. It's an old, horrible black and white picture, but it's a great picture. I'll show you a color picture of what it looks like. This was this rock we found, this outcrop. And to a geologist, an outcrop is rock that is in place. To give you an example, if you go out, say for instance, you walk in the Salt River, before they made Tempe Town Lake, places you still can do this. A bunch of rocks sitting out there. They're all pretty well rounded, but you don't know where those rocks came from. They got washed down by the rivers out of the mountains and stuff. So there's neat, you know there's rocks, and by the shapes of the rocks, you know, water's rounded them. But you don't know where those rocks came from. Now, if you go to Camelback Mountain and look at the rock or hike it, you see the rock sitting there in place. That rock has been sitting there since the day it was formed. That's called outcrop. And that's what this is here. This is not loose rock. This is rock that's born here where it's still here where it's born. It hasn't moved. And that's what you want because it tells you an awful lot of geologic information. And this rock now has told us that there was a lake there, maybe even an ocean, depending on what your definition of a lake or ocean is. But a giant standing body of water was on Mars in the past. When I say the past, we can't date any of this rock right now, but we're guessing it's probably 3 billion years ago, maybe 3.5 billion years ago. So, but standing water on Mars is a big deal. Because all of a sudden you got liquid water on Mars, you got to start thinking, was there life there? So, we've been thinking about lakes on Mars. I've worked on them for the last 15 years, but it's kind of like you think you see evidence, but we don't know for a fact. Now we have evidence in the rocks, and we measured that there was water there. Well, this was, you know, we get pretty excited. This is the guy who built the camera, took all these great pictures, Jim Bell. He's holding up 6 fingers because we got 6 wheels on Mars. These rovers have 6 wheels, and we did it twice. This is the second one. We drove off. And now we got 2 missions going, and this is a picture of the outcrop, the rock. And it looks pretty big and foreboding and ominous, but I'll show you how big it is. That's another close-up of it, but this is the rover, and that's how big that rock is. It's like a curve. You know, originally we called it the Great Wall. Well, it wasn't great and it wasn't a wall, so it's now officially called the Opportunity Ledge, but it's like a little curve, you know. So, but that's very important because it's the first outcrop we've ever seen on Mars to study. And we've gone up to it, drilled holes in it. This is a neat picture because it's a picture of the same rock before we did our rat hole. This is afterwards. I don't know if you ever took an intro geology class, but there's a mineral called hematite. And if hematite, you have a porcelain scratch plate, you scratch it, it leaves behind a red-brown streak. Well, when we ground into the rock, all this powder was produced. Sure enough, red-brown. We know hematite was here. We knew hematite was here. That's why we went here. Because hematite has something to do with waters involved in its formation. So that's why we went to the site. And it was just nice confirmation to see it like that. But other rocks we ground into, we didn't see it. We found more brighter, whiter-looking powder around there. So all rocks aren't the same on Mars. These are the famous blueberries on Mars. These blew us all away. No one had a clue we'd see anything like this on Mars. Rounded, spherical things. And these are made of hematite. And these are concretions that were deposited in water. That's how they form. On Earth, we have similar things. In Utah, there's a rock formation that has hematite nodules in it. Forms in water. And this is some of our remote sensing data showing the hematite peaks in here, which I don't spend a lot of time with viscosity group, but basically we know for a fact they are hematite. And I have 2 friends who are astronauts right now. They came out, I gave them a tour, and I joked around that this is the 2 NASA blueberries, looking at the blueberries on Mars. So, flight safe. This is Meridiani again. You can see how flat it is. There's our little crater we just drove out of right here. A little dinky crater. You can see our Bryson's on the rock. The tracks came out, and we've left our little home there now and gone elsewhere. We came across these strange fractures in the plains. We're not, to this day, not really sure how they formed. They're like little crevasses. We've driven across them. They're pretty safe, but we don't know what formed them. You can see more of the rock here also. Look at some strange things we see on Mars. This is a UFO on Mars. It was an unidentified flying object. To this day, we're not sure what it was. It's pretty remarkable we even got a picture of it. We're taking pictures, and look at the Martian atmosphere, the sky, this green streak we saw. It could have been a meteor burning up the atmosphere, or it could have been a spacecraft, and we're not sure which one, but the best, most likely candidate is Viking Orbiter 2 that went to orbit around Mars in 1976, an American spacecraft. We don't have the precise orbital mechanics of all these things out there. We know they're in certain orbits. We don't track them anymore because their propulsion systems have given out. They're in orbit, but they're not in orbits we can track precisely. So we think it's maybe Viking 2, but we really don't know what this is. You know? There's no little green man, I don't think. This is kind of neat. It's a picture of us. The first picture ever taken from the surface of Mars, looking back at the Earth. Here we are, right here.
Oh man.
And it's remarkable. I mean, these are just neat pictures that make you think about stuff. We've also done astronomy from the surface of Mars. This is the sun back here. This is like, you know, call it an eclipse of one of the Martian moons coming across here. This is the moon Phobos. Mars has two moons, kind of shaped like baked potatoes. And they're like about 15, 20 miles wide. And you can see that this one moves across this of the sun here, continues to move, and it's out of the way right there. It's a time-lapse sequence right there. So we've seen the moons go across the face of the sun from Mars with our cameras. And after we reached the 90-day mark, the first rover, we had a little party and a cake. We survived our 90 days. And this was the cake they made out. A day on Mars we call a sol. We don't want to call it a day because it gets confused with the Earth day. There's a 40-minute difference roughly. So, you're like sol 140. That's day 140 since we landed on Mars. So this is 91. We officially passed our 90-day mark. We had a cake to eat. And this is kind of showing what our long-range plans are for the Gusev landing site, for the rover called Spirit, the first one to land. The big crater we thought was a lake. We landed, drove to this crater Bonneville, and we were heading out here. These are the Columbia Hills we're starting to see here. Right now, today, we're probably sitting about right out here. And like I said, within about a week, depending if everything works in the rovers, we have little hiccups and problems every now and then. But hopefully we should be here in the first part of the Columbia Hills, this area called West Spur right now. Maybe by the end of this coming up week. And these are the Columbia Hills in color. This is a long way away. We took a long time ago. But now we're going to be driving around these things, looking around, and figure out what they are. So that's going to be a whole new mission starting. There are some intriguing things we're seeing out there. This is from the rim of this crater in Bonneville back in March. These cameras are equivalent to 20/20 vision of a human. Looking at the hills, I can see things that I've given. This is part of a science presentation I gave. Appear to be terraces running around through here. Maybe impact craters up here. This could be a landslide deposit. We're not really sure right now. But the neat thing is, we're going to find out what's going on here, and it's going to happen very soon. This is the second rover. It's a little Eagle crater we landed in. We've driven out, and now, like I said, we're sitting about right here, the Endurance crater. And then we're going to go drive around the rest of the crater, investigate it. We're still debating if we're going to go down into the crater or not. We're concerned if we go into it, we may never get out. Some of the slopes are pretty steep. There's a lot of loose material in there. If you get in there, you never get out, your mission's over. There's a lot of other neat things to explore to the south. I think there's a group of us that don't want to die in here. We want to continue south. I think we're going to win out. I think what we're going to do up here is what we call a toe dip. Go down and just dip our toe into the crater a little bit, try to analyze some of the rock, but don't go too far into it. These are some pictures that just came down. Unfortunately, they're just black and white right now. These are brand new pictures of Endurance Crater, looking at the rock in there. And Endurance Crater has some of the similar rock we saw back at Eagle Crater. Well, Eagle Crater is where we are 750 meters away. This is the rock that was put down in water, underwater. So now we know this body of water stretched at least 750 meters. Probably now we can confidently say it's bigger than that. But we had to confirm it with ground truth by going over there and looking at it. All these little round things here are the blueberries. They're all over the place. They're about the size of a BB. This is a picture looking inside the crater. Here's the rim of the crater. We're kind of tilted looking into it. This is actually the flat plain back here. This is some of the outcrop in Endurance Crater, which is about 30 times thicker than what we had at Eagle. When we first landed here, it's like this thick. Now where we are, we see some 30 times that thickness. A lot more rock history there, but unfortunately a lot of steep walls and cliffs we can't get into. We're trying to do remote sensing, look at it from remotely with our cameras and spectrometers to figure out what the rock types are. And there's probably hard to tell what's going on here. This is the floor of the crater. These are field of sand dunes down there. The crater is about the size of football, about the size of Sun Devil Stadium. The future right now, the vision the president has laid out for NASA is developed. The space shuttle is going to be retired in 2010. Right? The space station will be completed by then. And then there's going to be a new vehicle called the Crew Exploration Vehicle that's going to be developed. This will allow us to explore beyond low Earth orbit, go to the moon, and eventually go on to Mars in this vehicle. Like I said, there's a big budget fight looming. We're going to see if the budget's going to be approved in Congress. Hopefully it's going to get through. But the bottom line is that there's a goal for NASA to go somewhere again, which is what we've been needing to do. And hopefully, I think it's going to happen in our lifetime. I think, I'm optimistic. Hopefully around 20 years or so from now, first human being to be set foot on Mars. And this won't, all we have now is to rely on artist renditions. Hopefully someday somebody come give you a talk, show you a real astronaut stepping off the ladder there. And John Updike wrote a poem about the rovers. I'll leave this up, I don't know if you can read it. I'll leave it up for a second. I'll come back to it. He wrote this. This was published, I think, back in January or February in New Yorker magazine. So he wrote a little poem about the two rovers up there exploring. So these missions really have captivated not only people in the United States, but around the world. The websites that we have, Susan mentioned, they've got, I think now, close to 10 billion hits. You know, people are just been eating this stuff up. To give you an idea, that's more hits than any government website ever gets. NASA never even gets that much. The previous year never got a fraction of that. So people are interested in these rovers. And people are interested in Mars and space exploration in general. And I believe that's my last slide, yeah. So I'll shut up, and if you have any questions, I'll try to answer them. If you want me to scroll back to a specific image, I can do that. So hopefully I didn't put you to sleep. It's kind of dark in here, and I'm kind of worried sometimes. But any questions? Yeah.
First question, I was watching Channel 8 about a week ago, and it said that we believe that Mars once had a magnetic field,
Right.
and it was lost, and the solar winds blew all the atmosphere and the water off the planet. Now, can you comment on that?
Yeah, I saw the same program, and that's true. Mars used to have a magnetic field. It used to be stronger than the one that we have presently on Earth. And you know, we have this thing around Earth called Van Allen radiation belts. They protect us from all the nasty cosmic rays and solar particles coming in, the radiation from deep space to keep us so we don't have these mutations in our body and so we can live down here. Well, Mars used to have one of these once upon a time, early in its history, like the first billion years or so of its history. It's gone now. And it was detected from an orbiting spacecraft called Mars Global Surveyor. And it was very important because up until that time, we never had proof that Mars ever had a magnetic field. We found it locked up in the rocks, measuring these real sensitive basic magnets from orbit. You see rocks that have a lot of iron and magnesium in there locked up like little compasses. And we found out Mars used to have a magnetic field, but it's gone. The reason we think it's gone is because on the Earth, you know, we have active volcanoes spewing, we have plate tectonics. The Earth is alive geologically right now. So we have earthquakes, all these consequences of plate tectonics. And as the Earth spins on its axis, you have this molten core of iron and nickel. It's rotating also. And as it's rotating, it creates a magnetic field. This magnetic field, we really literally need it to stay alive down here. And Mars had that early in its history. And we see giant volcanoes on Mars, bigger than anything here. There's a volcano on Mars, Olympus Mons, 16 miles high, we covered the whole state of Arizona up. So Mars had volcanoes in the past, and it had this liquid core of iron and sulfur on Mars. And it did generate a magnetic field. But we think Mars, you know, is half the size of the Earth. The planetary engine kind of froze. It's real small. Couldn't keep the heat trapped in its inside, and it cooled off. And there still could be, we don't know if Mars could still have volcanoes every now and then to pop off or not. We don't know. We haven't seen that. But as that internal engine, geologic engine, froze up, magnetic field froze up too. It died, went away. And when that went away, the Martian atmosphere, like you said correctly, solar winds streaming out from the sun, these particles, strip off parts of the atmosphere, eventually probably took a lot of the Martian atmosphere away. Mars had a very different atmosphere in the past. Like I said, it's a very cold place right now, very low atmospheric pressure. If you're an astronaut on Mars right now and opened a bottle of water, it would boil away before your very eyes. You're probably thinking, oh shoot, this guy's lying. He says it's cold up there. Why is it boiling? No, it's boiling away because the atmospheric pressure is so low. If you ever gone up the mountains in Flagstaff trying to boil water, it takes a little different time to boil than it does here closer to sea level. It's the pressure. So on Mars, the pressure is very low. Liquid water cannot exist on Mars today. Well, we know that's wrong because we found evidence that there was a lake at one of our landing sites right now for the minerals that were deposited in water. And also from orbit, we see all these dried up riverbeds all over the place on Mars. Kind of like flying an airplane over southwestern United States. All these arroyos and gullies you see on Mars. So we know water, once upon a time, was on Mars, liquid water. It's not there now. And as the atmosphere got stripped away, like you're talking about, the magnetic field went away. A lot of that water is on the surface froze into ice, is now locked up in the ground called permafrost. And so Mars, you hear about climate change on Earth all the time. This movie just started Friday afternoon or Friday day after tomorrow, is the name of it. Mars did have a dramatic, drastic climate change. When it happened and why, we don't really know. The fact that magnetic field went away played a role in there. There could have been big impacts in there blowing off part of the atmosphere. But that's one of the things we're trying to figure out is water distribution, has about the climate. So Mars no longer has that field. And also Mars, you hear about the ozone hole on Earth? You know, the ozone hole. Well, Mars has no ozone at all. It's a global ozone hole. Ultraviolet radiation goes right to the surfaces, and it's not very good for organic compounds. Just zap and fry them. So anything alive on Mars today, if it is there, it's probably underground, we think, or inside rocks, if it's there. We're not sure if it's there or not. Just based on my experience in Antarctica and these other weird places around the world, I'm not a biologist, so I'm kind of talking out of my field, but if life ever gets a foothold, it's going to figure out how to stay there. You got mold in your bathtub? You can't get rid of it very easy, can you? So it learns how to adapt. It's pretty tenacious. So if life ever gets started on Mars, the things I've seen in remote, extreme environments on Earth, I think it's probably still there. When I talk about life on Mars, I'm talking about microbes, primitive organisms, you know. There's no people or plants or anything walking around Mars. So that's, you know, but we're trying to figure all this stuff out. Yeah.
What's the difference in the visual spectrum because of atmospheric difference?
If you're on Mars as a human, like looking through your spacesuit visor, it's filtered a little different. The sky is kind of pink looking because of all the dust up there primarily. The atmosphere is so thin, so it doesn't really have much of a shift. Everything would probably have more of a little reddish tinge to it because of the red in the atmosphere kind of reflecting, but it wouldn't be anything dramatic. It's interesting, on sunset on Earth, you know, the sky gets kind of reddish and orange because of all the dust and pollution in the atmosphere. But on Mars, the opposite happens. Most of the time on Mars, you look at the sky, it's kind of a salmon color, kind of pinkish because of all the red dust up there. At sunset, we took pictures, it gets kind of blue. That reverse what we have here. So that's kind of a neat thing. But yeah, everything would kind of have a reddish kind of tinge sort of to it. I mean, not overly dramatic, but you would notice things. Like if you look at your white spacesuit, probably it have more of a kind of a reddish tinge to it. And once that dust gets on there, it really makes it nasty. Yeah.
Any work been done on making like a relief map of the entire planet, the surface of the entire planet of Mars, and trying to figure out at what level an ocean might have been, or where rivers might have been that flowed into an ocean?
Yeah, there's an instrument that was on Mars Global Surveyor called MOLA. It's a laser altimeter, shooting laser beams down, making topographic maps of the planet. And we have the whole planet mapped that way now. And in terms of like a quote-unquote Martian sea level, there are some areas, Mars, the southern part of Mars is higher in elevation than the northern hemisphere. The southern hemisphere is higher, has more craters, it's older. The northern hemisphere is lower. And we think those could have been maybe, some people speculate those could have been ocean basins in there. Thing is, we don't really see shorelines, but if you think about something being billions of years old, being battered by erosion forces and impact, it could have weathered those things away. I think there's no doubt there are lakes on Mars, we know now, and in terms of a giant northern plains ocean, that's still a controversial thing among scientists. Some people, a friend of mine thinks definitely there was. I think there are large lakes on Mars. I like the word lake better than ocean. That's just semantics. But we do see places based on topography that water could have ponded up in little basins in there, yeah, in the northern plains. Huh?
Is there any weather at all on Mars?
Yeah, there's Mars is. You hear about these dust storms that happen on Mars, and they can enshroud the whole planet in dust. That happens in the Martian orbit when it gets real close to the sun. The southern hemisphere heats up, generates all these dust storms. And we have also got pictures of water vapor clouds on Mars, but you don't see a whole lot of clouds on Mars. It's very thin, and to kind of confuse you, the Martian atmosphere is saturated with water, but it's very thin, remember? So if you took the Martian atmosphere and squeezed it, you might get the equivalent moisture in the palm of your hand. It's measured in precipitable microns, but there is water vapor there, so it does form ice clouds. And these dust clouds are basically dust that's coming up. It has little dust devils. We've seen pictures from orbit and even from the ground. So it sort of has weather. Mars does have climates. It tilts on its axis like the Earth. So it does have seasons like we have here. They're about twice as long. These dust storms are very nasty because they can, for solar-powered vehicles, they don't get that much sunlight and lose their battery power. And our rovers are solar-powered. We haven't had any dust storms right now, but dust continually rains out of the atmosphere. It starts accumulating on the panels and cuts down attenuation of sun getting on the panel cells. But yeah, it has weather, but it's It's not like you think here. There's no big storms. And when you hear about Martian dust storms, sometimes they're erroneously called sandstorms, but they're not sand, it's dust. You hear wind speeds like 250 miles an hour. Well, that's what they're going, but to us, it would feel like about a 25-mile-an-hour wind in the atmosphere. It doesn't have that much force behind it, so thin. Yeah.
Yeah, that it lost its magnetic field. Does that mean that the planet is solid? There's no more core movement inside?
We think, we don't really know enough about geophysics, internal processes on Mars, but we think that core probably is pretty much, frozen solid pretty much. It still could be a little mushy in places, but overall it's probably pretty much locked up as a solid ball of rock down there now. Because if it was active, you'd expect to see a lot more volcanoes popping off. And some of the lava flows on Mars, the way we date them, we count craters, believe it or not. The more craters the surface has, the older it is. The fewer the craters, the younger. It's a relative scheme. And we do see lava flows on Mars that we think are very young. And when I say young, they're geologically young. They're like around 10 million years old. To a geologist, that's like last week. So we see some of those, and that tells us that there are eruptions going on maybe about 10 million years ago. So maybe in places there are localized little hot spots where you can still have activity. But we haven't seen any type of volcanic eruption since our spacecraft has been there, which has only been in the last every 5 years or so. Yeah?
How long do you think the rovers are going to continue to keep working?
That's a good question. We just had a presentation Friday afternoon from one of the engineers, and they're talking about going to October 2005.
Wow.
It's going to depend on money. I have a hard time believing that NASA is going to pull the plug on these successful rovers because they're working so well. It's so hard to get there just based on money. The money is, most of the money's been spent to get them there. All that's been spent now. It's a trivial amount to keep them going. But right now we're in the extended mission phase. To give you an idea, our extended mission phase, we got I think it's around $12 million to continue on through September of this year. The thing is, something could go wrong tomorrow morning. They could both die. Software error. It's going through some dramatic temperature shifts up there. From daytime temperature to nighttime temperature is a swing of over 100 degrees. If you do that in and out a lot of times, you start wearing out components. Computer chips might want to just start breaking on you. We have to have heaters to keep instruments warm at night. It's getting down around 60 below zero at night. It's going to get colder. We're getting to Martian winter right now. So if we can survive until like probably the winter ends and spring comes back, which is going to be like the fall for us down here, if we survive that period, the sun will come back up higher in the sky. We'll get more energy and keep going. But yeah, we're talking about going possibly till a year and a half from now, which is unbelievable. I mean, NASA's trying to figure out how we're going to work this mission this long. They weren't supposed to go this long. And to me, it's a national resource we have up there right now. To pull the plug would be almost a crime. I mean, it's so hard to get these things there. And the day they will die sooner or later. Hopefully it's going to be later. It's going to be kind of a sad day. I mean, we've been living with these things that's on the science team before they were even launched, and now intimately on the surface working with them. And they're like our robotic emissaries as field geologists. And they sort of have personalities. One rover, the first one to land, Spirit, has had a bunch of little, we call them hiccups, a flash memory problem. It had little anomalies that pop up. But it's more rebellious. But it always kind of comes back to the fold, and we fix it, it does what we tell it to do. The weather rover, Opportunity, really hasn't. It landed, the night it landed, a heater got stuck on. They couldn't turn it off. Engineers couldn't turn it off. It's been draining power since the night we landed. And our science operations are down to about an hour a day right now. Normally they're about 4 or 5. That's really cutting into our operations and our knowledge base. So what we're having to do now is something called deep sleep. We put the rover to sleep at night, turn off all power, and hope it wakes up in the morning. One day it might not. But what happens, we feel pretty confident, we've done this a couple times now, we turn off all alarm clocks, all power, it just sits there, hibernates. When the sun rises in the morning, so the sun rays hit those solar cells, it wakes itself up that way. So we've got to hope it keeps doing that. So far, it looks pretty safe, or we'll be doing it. Yeah.
The ultimate purpose of space exploration supposedly is the colonization of space by human beings. Do you think that is possible? If it's not possible, what's the purpose of the exploration?
That's my personal opinion. Other people have other opinions that work on these projects. You always hear this man versus unmanned kind of like argument of space exploration. And reality to me, that's kind of a fallacy. I think they always work both together, manned and unmanned exploration. But to answer your question, I think we will colonize Mars. I think that's what it's all about. It's a couple hundred years down the road right now. we're not gonna see that come to fruition. We're gonna see those first steps lay the foundation for that. I have no doubt it's gonna happen. I mean, like I said, Columbus and, Spanish and the French and English, came over here, colonized this area. So the same thing will happen. I have no doubt. It remains to be seen what country will lead it. We may not be the leaders. We shirk our responsibility and the challenge of doing that. Chinese are gonna pick it up, the Europeans, the Russians, somebody will do it. Hopefully it's gonna be the United States, but, I think it's inevitable. We'll have it. I mean, I have no doubt in my mind on that.
But if you're looking for a dead planet to colonize, why not the moon, which if they reach in 5 days,
Well,
6 months to reach Mars?
the moon is a lot closer, and that's kind of one reason we're going to go back to the moon before we go to Mars, for a couple reasons. To learn how to explore again. The space station, the space shuttle, has been operational, the mentality, how to build. The space station has been very useful because it's taught us how to build big structures in space. We didn't know how to do that. Now it's going to give us some information on life science about the human body. The moon is very close. If something goes wrong, you turn around and come back home. The thing about the moon, the problem with the moon is it has no atmosphere at all. Mars is very thin, but it has one. The moon has no water. There's some results, analyzing results, there could be some water at the poles of the moon, frozen, ice from comets and stuff. That's not confirmed. It's kind of debatable in the scientific community if it's really ice we think it is. The other problem is it's going to be so cold, it's in perpetually shadowed areas of the moon. It's always in shadow, so its temperatures are several hundred degrees below zero. You got to think, how are you going to mine that stuff out? A scientist just gave testimony before in Congress a month ago. There are no known metals we have on Earth that can mine at those temperatures without shattering. So how are you going to dig in the ground and get that ice out of there if your equipment's breaking apart? How are you going to do it? So the moon has a lot of problems in terms of resources. Mars, we can live off the land because the water is there. We can probably set up greenhouses. There's CO2 gas there on Mars, the atmosphere. Plants taking CO2, give off oxygen. You set up a greenhouse, start creating your own oxygen, have plants to eat, start a cycle. But this is going to take a lot of work. So I think we'll go to the moon as a test bed to learn how to go to Mars. But to set up a base on the moon has been talked about, observatories. I think that may happen. But you're continually going to keep supplying resources from the Earth to the moon to keep the water, stuff like that. There's oxygen on the moon, but it's locked up in the rock. You got to melt that rock to get it out of there. It takes a lot of energy. It's more efficient to take it, just dig in the ground, get a block of ice, and melt it, filter it out. But I think we'll do both, and it remains to be seen. But right now, the way it's set up is we'll go to the moon, test out technologies, techniques, and book on over to Mars. And hopefully that's going to happen. I'm concerned about it is Mars, we put on the back burner, and all the resources and money we spend on the moon, building a moon base or observatories to the far side of the moon. In Mars, never happens. That's not the way it's set up right now. Let's see how it all plays out. It's still early right now. Yeah.
I have a really strange friend named Richard Hoagland that I
Oh, yeah.
remember from Star Trek days when he was a little bit more sane. He believes that there is a face. I know that they've since taken photographs that disprove this, but he has gone to great lengths and made a whole career out of mapping the so-called city and the pyramids and the this and the that. Are they ever going to go there just so they can debunk that?
Probably not. Not just for that reason. Not just for his reason. I mean, we're not going to let him direct the goal of Martian exploration. He's not even a scientist. I don't want to say anything else, but I think he's doing. I don't know. I don't want to say more about it because a lot of this stuff is just sheer nonsense. If there was a face on Mars and civilization on Mars, as a scientist, we'd be going there. But scientists like to talk about what we do. If you don't have a mission to make a discovery, you're going to have a Nobel Prize in science for finding proof of an alien intelligent civilization in the world. Why would we cover that up? I mean, he just kind of tries to put NASA. Well, I'll tell you for a fact, I work at ASU, but my money comes from NASA. So I'm basically sort of a NASA employee. ASU is a subcontractor to NASA, to think of it. NASA does not tell me what to say or not to say. And there's a lot of this fringe science going on out there, especially doing space exploration, is what I'm more familiar with. A couple of years ago, when I worked on that mission that crashed on Mars, I was living in Tucson, working at the University of Arizona there, and I went to this meeting. Jim Colby was the House of Representatives, was there giving a talk, and I met him afterwards and talked to him to see what his support was for NASA and for going to Mars. And this guy in the crowd comes up and says, well, that polar lander's working on Mars right now, sending pictures back. I was like, you're a liar. I said, how do you know? I said, because I worked on that camera. I can tell you for a fact there's not one picture on that. So, you know, and I said, where'd you do that? Oh, a friend of mine works for the CIA. Well, so first of all, the CIA would not know how to work the camera. This camera is a very sophisticated, complicated device. We spend years learning the software and how to work these things. You know, it's not that doesn't work like that, and it's just a lot of that out there that NASA's in conspiratorial mood, keeping things from the public. To me, it's the most ridiculous thing I've ever heard about. Why would we want to do that? And some people say, well, our civilization and society can't take proof of an intelligent civilization beyond ours out there. You know, if they're out there, they're coming here, how are you going to cover that up? I just, you know, if they're really doing that, they could have conquered us by now if they wanted this. I don't know, I just think it's, I don't know, at Hope Field is, you know, those people you can never convince, because for years he maintained the space on Mars. And when that picture was taken of the Viking spacecraft in the late 1970s, it looked like a face. The scientists said it looked like a face on Mars. It did. You've probably seen clouds. Y'all been in Sedona? You seen Coffee Pot Rock? Snooky Rock? Any of you for one moment think aliens carved that out of the rock? No. Natural geologic forces and time. Same thing with this so-called face on Mars. It looks like that. That doesn't mean it is. You see dragons in clouds. That means they're dragons that they're floating in our atmosphere. I don't think so. So it's a natural rock formation. The way the sun was hitting it, it looked like a face at the time. Well, the resolution of that camera, the smallest it could see was something about the size of a football field. Okay, it's late 1970s. Mars Global Surveyor, which you've heard me mention several times, has a camera on there. They can see something the size of a car on Mars now. Okay, and we took a picture of the face because it was all this clamor about the face. And well, the picture came back. It didn't look anything like a face. It was a rubble pile of rock, a plateau, like a mesa. Nothing like a face. You can look at the website, check it out, and decide for yourself. You have to believe me. Well, Hoagland and the people had a story. Well, NASA dropped an atomic bomb on the face where he took the picture, so he wouldn't. Yeah, win with it. So I've already given it too much talk.
First of all, I predict we'll find a Darwin fish before face. Do you have, since we've gotten off a little bit from Mars, do you have any information on the Saturn thing?
Cassini mission.
I'm
I'm not a science team member on that one, so I know a little bit, but it's not my expertise. But we're supposed to go, I think, into orbit around Saturn on July 1st this year.
Yeah.
It's going to be a remarkable mission. It's going to orbit Saturn, some of its moons, send back pictures, be the most detailed information of that system ever. Previously, all we had is flybys through the system, Voyager 1 and 2 flybys back in late, I guess, 1980, 81, somewhere in there. And we're going to orbit the planet, look at some of the moons. There's a probe called Huygens probe, which is going to enter this moon around Saturn called Titan. This moon is about the size of the planet Mercury, very big. It's got a very thick atmosphere. You know, we've been talking about Mars' atmosphere being very thin. This atmosphere on Titan is thicker than the atmosphere here on Earth. It's mostly liquid nitrogen, and it's real cold out there. And we think there could possibly be seas out there, seas of like methane and ethane, gasoline type products. It's very cold, so it's so cold that things that are normally gases are liquids there. We don't know what we're going to find. This probe is going to enter the atmosphere, come on a parachute, it's going to land on the surface of this moon. I think it's going to happen, I think it's like early next year, I think. I could be wrong on that, but it may be floating in fluid or maybe on solid, like ice. We don't know right now. But that's going to change our whole thinking of that system out there, and that's going to be a neat mission. I kind of wish I was working on that one too, but I'm a diehard Mars person. I'm a Mars chauvinist. So,
there is going to be, excuse me, a close flyby of the
Phoebe.
moon, Phoebe,
Yeah.
in about a week.
Yeah.
So that'll be the first results from the system.
That's going to be a neat one. There's already been beautiful pictures coming back from the spacecraft already. And they have a website, I don't know what it is, look at JPL, Jet Propulsion Laboratory, and I'm sure that'll be covered a lot. But yeah, NASA's going to, so far, you had rover missions and Cassini's coming up. Cassini's going to be there for years. It's going to, revolutionize our knowledge, just like the Galileo project did for a Jupiter system. Yeah.
Yeah, the photograph you showed looking back at the Earth, I noted there weren't a lot of stars or anything showing.
Yeah. I'm sorry.
Was that like shut down or?
Yeah, you have to put it on exposure so you can only see the brightest object. And you also got to account for the planets rotating, so you don't get smeared. If you ever take astrophotography with a telescope, you have to have a motor on your telescope to move it if you want to keep pictures of the moon or whatever your object of interest is. If not, you get all these streaks in it because the Earth's rotating and the stars have a streak behind them. And that kind of reminds me of something else. I teach a intro planetary geology class at Scottsdale Community College, a night class. And when I first started teaching this class, I just asked people, this show came on Fox TV a couple of years ago about moon landings are fake. And I said, is anybody in here, I said, it's your own opinion, you can do what you want, you believe that those are fake, we're going to land on the moon. I couldn't believe that people raised their hand thought it was all a hoax. And I never thought, in a lot of imagination, that I'd teach a class in planetary geology and talk about proof that we landed on the moon. But one of those lines of evidence that made me think of this is the astronauts' photos from the moon, surface of the moon, the stars were never there. You could never see them. But you can see pictures of the Earth. People say, well, that's proof that it's fake. I think NASA's that dumb to overlook that idea, that detail. It'd be, first of all, that's a problem. But the reason you don't see stars in pictures from the surface of the moon, because they're so faint. Remember, the astronauts are on the moon during the lunar daylight. Okay, a day on the moon is what lasts 2 Earth weeks, and a night on the moon is 2 Earth weeks. So they landed in daytime. So first of all, and the cameras were at the right settings. That you only want to see the bright objects. You want to see the dim stuff. And things, you give a camera, the f-stops and things, you can figure out. Go out at night with an instamatic camera, take a picture of the night sky. You won't see any stars in that picture.
Why was the flag moving on the moon?
Okay, that's a good one. The flag was moving for a couple of reasons. Some of that footage they showed in that documentary didn't show the astronauts putting the flagpole on the surface wiggling. And what happened is there's no atmosphere on the moon. They had springs coming out to keep the flag extended. So they had to knock a hole in the ground, put the flag in there, and wiggle it in there. That's one reason. But another view is when they lifted off from the moon, actually the first flag from Apollo 11 got blown down. They lifted off the ascent stage. The rocket exhaust came out, blew the flag down. The astronauts saw it fall over when they took off. So that's the reason the flag kind of flutters in those views. Yeah.
I presume that you people had a selected place to land, like Woodstock crater. How do you manage to even get close to it?
Yeah, that process I kind of glossed over. It took us about 2 years to select the final landing sites. I was involved with landing site selection, and you had a certain criteria the engineers give you. It has to be a certain elevation for the parachutes and airbags to open. It has to be certain latitudes for the solar energy, so it's near the equator, maximum solar energy. So you don't want it too rocky because it's going to rip the airbags apart. You got to create a new crater on Mars. So you don't real steep slopes. You don't want it real dusty because all the dust gets on your solar panels once you drive off the lander. So you got these criteria that keep you kind of in a constraint field. And then inside that constraint field, you got a lot of sites. We started out with about 200 candidate landing sites. And what we did is, all of us who were involved in this process, as geologists, we'd go back and look at the images from orbit and all the data we had. And then we'd have a meeting about maybe twice a year. Everybody would get together, kind of like this, in a room in a hotel, and give presentations and kind of like a salesman. But you had to have your stuff in line because you're getting grilled by the scientists and engineers about, is your stuff really achievable? Is this really the best place to go? And you wanted to go somewhere there was evidence of water in the past. These missions were about trying to find places where there was water in the past and Mars existed. So that kind of gives you ideas of places to go. You look for channels or certain mineral signatures. So to make a long story short, we finally got it down to 4 sites. And those 4 sites we had to figure out, basically voted on. So all the evidence was collected, presented. We voted as a team which sites to go to. And we selected these 2. I think we selected the best 2. One of them has turned out to be a gold mine, Meridiani. Gusev Crater so far has been a dud. We haven't seen any shred of evidence that a lake existed there. There's a lot of reasons for that. It could be that the lake beds are buried below a bunch of volcanic lava flows that flowed in there afterwards. I mean, we're talking about billions of years of history. And but every day when you say something like this, like we haven't seen anything, you already got to preface it with so far, because these things drive home. Who knows, when we get to Columbia Hills, what we're going to find in there. We don't know. It could be more volcanic rock like we've seen at Gusev. But we do see some layering in that rock. Maybe that's some sedimentary rock. We don't know. And that's what we're going to find out. So stay tuned for that one.
My question isn't quite answered in my mind. How do you manage to steer this thing?
Okay, steer it in there, okay. What you have is these landing ellipses, like I said, about 120 kilometers long, about around 20 wide. So the engineers can get somewhere in there. And you'll come in, what you do is, if you lift off from the Earth, the interplanetary cruise took us 7.5 months. But along the way, you have these mid-course correction burns to tweak it, keep it right where you want to go. And we had like 5 of these TCM burns, trajectory correction maneuvers. And as you come in, a couple weeks out, even one was even a couple hours out, if you're they have the nav team, with the radar communications, the radio, they know exactly where they are in the orbit of the planet. They can tell you where you're going to be in there. And if we were off, we could do one of these burns about 3 hours before entry. We didn't need to. We were so precise. And it's a lot of just detailed. I'm not a navigator, so if you want more detailed information, I can't help you in that. But it's tracking the thing with the Doppler shift out there. It's knowing rotation of Mars and the surface very well. It's equivalent, they said, of being in North America, shooting an arrow, hitting a target bullseye, something like that. The analogies, taking into effect winds and everything on Earth. So it's a hard thing to do, and it is amazing what happens with these missions. I mean, the more personally you get involved in them and know what's going on behind the scenes, it's amazing they ever work. I mean, there's some of this stuff has to go right. Yeah.
Is there any way possible that this could have been done without computers?
Nah, there's no way to even. I can't even fathom that.
I can't either.
I mean, even when we flew to the moon, the Apollo program, they had a computer on board. The computer in your car is more powerful than those astronauts had to fly to the moon in the 1960s. But you have to have that computer for the navigation, precise alignment, precise burning of rocket engines, precise maneuvers. I mean, they have to be just right on the button. You can't be 10 seconds later, you miss the whole planet or whatever.
But they had astronauts.
Yeah, astronauts help. I mean, I think I'm a big supporter of manned space flight. I mean, no bones about it. I think a person can do anything better than a machine will ever do. And people a lot of times say, well, one day we'll have machines capable of it. It's a long way away. I mean, these rovers are the most capable right now. They're stupid. We have to tell them everything to do up there. And they're very slow, cumbersome things. The work that's been accomplished up there thus far could have been done by an astronaut crew in a day or two. It got a lot further. Yeah.
How deep a hole can you dig with the wheel, and what would be the advantages of digging deeper?
Yeah, we dig these trenches on Mars. We have 6 wheels. We can lock 5 wheels up. We spin one. And the wheel's diameter is about 25 centimeters, so you get down about half that. And so we're getting around 10, 12 centimeters deepest trenches. It also depends on the material. It's sliding back in when you dig it. It's very tough, hard to get through. We've done a bunch of those, and the reason we want to dig down to the subsurface is because that stuff hasn't been getting bombarded by the UV light, hasn't been sitting out there with the wind and the dust getting on it. It's more fresh, more pristine materials. That's the same philosophy why we want to pour into the rock, get the dust off there, to get more pristine rock that hasn't been altered. And we do both. We get both 10-member sets to look at and compare, see the differences. And one day we want to do deep drilling on Mars. And if anybody, when I was in grad school, I had a job at an environmental geology firm here in the valley. And to do drilling, there's no way a robot's going to do that. That's too complicated. You're going to have astronauts involved. And deep drilling on Mars, do that to tap into the ground ice down there. But also, who knows what's alive? It pours out, read the rock history. And in the high latitudes on Mars, around 40 degrees towards the pole, you can get a shovel, go out there digging the ground, and hitting ground ice. Only about maybe 2 feet down, you start to get ice. It's a nice resource to have sitting there for crews to go, find that out, melt it, drink it, make rocket fuel, air to breathe. So that's something we know is on Mars. On the moon, it's debatable. Even how much is there, it's tough to get at. On Mars, it's there. We detected it from orbit, and that's just waiting for us to use, and I think we will. Yeah.
When you say ice, do you mean like a block of ice, or do you mean dirt that's got ice crystals that have formed over a period of time?
Yeah,
it's kind of like permafrost.
Yeah, it's like permafrost, exactly. It's like it is permafrost. It's mixed in with some dirt and maybe some salts and stuff in there. So you're going to have to mine it out. You're going to have to put it through some filtration systems where you can drink it. And who knows, it may have a salty taste because we know there's a lot of salts on Mars from a lot of bodies of water that dried up. That's kind of how one way we prove there's a lot of this lake on Mars is when water dries up, you see the little white line in your pots or your glasses out here. Those are salts that are minerals that are dissolved in liquid water. And that water evaporates, leaves those salts and minerals behind. And sometimes it forms caliche like out here, but it leaves certain things, signature minerals behind. And by knowing those minerals, we can tell that this thing was underwater at one time. Certain minerals only form in water. And so we got that nailed, I think, the open shut case. There's a lake. How deep it is, we don't know. This lake could have been only this deep on Mars. We don't know how deep it is. We can't constrain that with our instruments and what we've seen so far. And we don't know how long the lake lasted right now either. We need samples to get back on Earth. The subjective to more detailed analysis from our laboratory instruments here. A lot more complicated than what we fly on Mars. We can figure all those questions out. We can date it, see how old it is also. Yeah?
With the distance it is, could it have ever been
warm enough to bin liquid on Mars?
Well, if the pressure of the atmosphere was greater, you know, if you have a thicker atmosphere, it can be a little bit warmer. You can allow liquid water to exist. And, you know, liquid water was there, but I think Mars has always been cold. It's the fourth planet from the sun, you know, next one out from us. And I think it's always been fairly cold. I think, this is my personal opinion, because no one knows the answer to this, but from working in Antarctica and studying Mars these years, I think the best Mars ever got was Antarctica on a good day. Still a cold place, but in Antarctica, you have liquid water down there. You have these lakes that exist with ice covers. And for a couple weeks out of the year, liquid water is flowing on the surface. You know, little rivers and stuff in Antarctica. I think Mars could do something similar to that. I think it's always been fairly cold, though. Yeah.
Has Jupiter ever produced enough heat to warm it up?
Well, Jupiter,
1 billion years ago?
Jupiter, sometimes it's called a second sun in our solar system because it gives off like more radiation that kind of other planets do. They call it a failed star, but it's not massive enough to turn into a star. But Jupiter is it's the largest planet in our solar system. You could line up 10 Earths across the equator of Jupiter if you have how big it is. It's a massive ball of gas, and its gravitational attraction is like 200 times what we have here. And a lot of compression stuff is going on in the interior of Jupiter, and it is giving off a lot of radiant energy. The moons around Jupiter, like Europa, you've probably heard about, Ganymede, like a miniature solar system. They think that these little moons possibly could have, they're covered with ice or ice balls right now. They think there's a liquid ocean of water under the ice crust in Europa, and they think some of the heat and radiation given off of Jupiter could possibly allow some type of ecosystem to develop there. But Jupiter gives up a lot of radiation. Those moons are bathed in lethal doses of radiation that kill human beings if they're out there. You know, so it's not like a sun giving off energy, but it does create some radiant energy, like in form of radiation, not because of visible light, but more types of X-rays and stuff like that out there. Yeah.
Do you have any information about what the plans in the future are for the Hubble telescope?
Well, as you know, for a while, Hubble was going to be scrapped when these gyroscopes on there keep it aligned right, these batteries that help power it. And for a while, I just thought that they're going to, when those gyroscopes go out, they're going to let it go. They're not going to find more manned missions out there because it took astronauts to go out there to repair the equipment for Hubble. There's been several Hubble servicing missions the shuttle has supported. And it was thought that this is going to go. The reason it's going to go by the wayside is because Hubble still has a couple of years of life. They go until 2008, 2010. But if you send a crew to work on Hubble, they can't get to the space station. If they have a problem like Columbia did with the tiles, they're doomed. Right now, the thinking is that every shuttle that launches has to have the capability to go to the space station in case of emergency. The space station's a safe haven. The crew can get on there, can live, and wait till the next shuttle can orbit and get them, bring them home. If you go to the orbit of the Hubble, you don't have enough fuel to go back to the orbit where the station's at. So you can't do both. Now, Hubble looked like it was going to die. There's been a lot of talk in NASA now to re-looking at that issue. And they're thinking about maybe flying robotic missions to service it somehow. It's going to be a lot harder to do it. It's feasible. And there's even some talk that maybe fly a shuttle mission up there or something. They're looking at the issue again. Right? So that's not open and shut case like it was back in January, February. They said when Hubble goes, it's gone. I think people want to keep it going, but you got to understand the situation for manned space flight. If you launch a mission up there, if something goes wrong with the shuttle, those guys are going to die probably. So you want that station back. That's the reason it's happening, because you can't do both. You know, the orbit, they're in different planes, and you can't just, you know, it's not like going to 7-Eleven here and take off and go to ASU. It's not that easy. It's different orbits, and the fuel, you have limited amounts of fuel in the shuttle when they launch it. You can't just burn all the fuel to shut Hubble and try to make it down to the station. You can't. That's what happened with Columbia. Columbia could never have gone to the space station. People say, well, how come they guys didn't go to the station? They weren't in the right orbit, and they never had the fuel to do it. Yeah, in fact.
But what you're doing is arguing against manned space flight.
How?
I mean, you want to go to Mars, but you can't go to the Hubble because
Well,
there's no safe place. There's no safe place in interplanetary space for these guys to hide.
The bottom line is manned space flight's dangerous. I mean,
Yeah.
it's going to be dangerous. You're riding a controlled explosion at liftoff, and there's a lot of things. And I think, unfortunately, our society is, I think, got guts or chickens, basically, I think. We're kind of gutless. If something happens, we're like, oh, we broke our fingernail, we better stay home today. You know, it's like, the mentality we have today, we couldn't have gone to the moon in the 1960s, I don't think. It's kind of a sad commentary on society, I think, in a way. But The Hubble, they don't want to do that now because if you, okay, say you launch a mission to prepare Hubble, something goes wrong, those guys die. You imagine the clamor? You knew you shouldn't have sent them there. You did it anyway. We're cutting all your budget, but you did something to rescue people's lives or that. NASA's in a tight little spot on that one because, you know, you saw the clamor after Columbia. No more manned space flight after the Columbia accident. It's too dangerous. We shouldn't risk, you know, spend all this money and lives for that. So people, and that it's not NASA, it's people can have both ways down here who hold purse strings. You know, they can't, you know, say, you know, not give you the proper funding to do this, and then say, well, go fix that thing now. And if something goes wrong, they all run, hide. You know, if you want to blame anybody for the Columbia accident or the Challenger accident, people in Congress ought to look at themselves in the mirror because NASA's budget hasn't been sufficiently supplied to fly these things. And I know personally from some astronauts who go to Capitol Hill every year, they've told some members of Congress, if you don't want to fund it, and scrap the whole thing, it's going to die. You know, these things are expensive and it's complicated, and you know, and accidents are going to continue to happen. They're never going to go away. And going to Mars, I think the first mission to Mars, manned mission to Mars, one of the crew members or a couple will be either seriously injured or they can die. And right now, if we go to Mars, the trip takes 2.5 to 3 years under present-day chemical rockets that we have. It's a long time to be gone. And think about what happens if you get down here 2.5 to 3 years. It's pretty safe. But there are people who are doing it, thank goodness. So people want to take those chances and think that it's worth the rewards. And so, yeah, personally, I think, you know, with the situation, the climate, we can't afford people dying in space. That's an unrealistic view. It's going to happen again.
Let's take one more question.
We lose more people in Iraq in a week.
Oh, yeah. Who hasn't asked me when it's back? Yeah.
For comparison, do you have any idea how many men Columbus lost?
I know about Magellan. Columbus, I don't know. I should not know. I don't know. Magellan left with, let's see, 5 ships. He was the first person to circumnavigate the globe. Crew of about 220 people. Came back with 1 ship. Magellan didn't make it, and 18 people. A lot of them. You know, some large boat didn't make it around there. Lewis and Clark had about 43 people. Only 1 person died. For Columbus, I don't know that number. I appreciate your time.
If you appreciate the Humanist Society of Greater Phoenix and would like to see more, then subscribe to our channel and check us out on Patreon. Links are in the description.